Good evening, everyone. Welcome to the Death Valley region of California. My name is Mike Jerry, and we've got some cool astronomy to do tonight. Let me make sure my audio is off over here so I'm not echoing all over the place. Okay, so tonight we got some pretty objects to look at, some end of summer things, and some maybe even a couple things coming up for more of the winter skies. As you can tell, I got a little bit of a breeze tonight. It's supposed to be not much of anything, and got little puffs and that's it, but it should be minor enough to not cause us any issues, other than me having to go get another layer on or something here pretty soon. In any event, let's turn off this test pattern and let's start with my setup. And here it is. This is my telescope is an 8-inch Celestron Schmidt-Cassegrain telescope up here, and so 8 inches of aperture. And I'm running a Arizona Hyperstar on the front of it, which makes it optically very fast, which is great for imaging. And so, yeah, the camera's stuck in here, and I'm at a table behind here, just sending you all this good stuff. The mount I'm using is a ZWO AM5 harmonic strain wave mount. And it's all riding on my spare no expense cinder block pier, as always. So let's take a look. Okay, so we used Nunkey as our focusing star, and that's that one right there. And I've got my targets kind of highlighted here. First, I think we'll just start with a real pretty one right here next door, which is the Trifid Nebula. And I may even be able to, if I play my cards right here, possible I'll maybe be able to get some of Lagoon in here as well, which would be kind of cool, because that's another pretty one. Yeah, let's keep working our way over here. Yeah, I think I can get both of them in there. That should work. Alright, let's send the scope over there and see if we can get these two. This is some of the nice summer stuff that, yeah, there they are right there, that is going to be leaving us here soon. And there's a satellite bombing right through. You can probably see that. That's going to be unfortunately, that is a characteristic of one of the prices you pay for shooting the western sky very soon after sunset, is you're going to pick up a lot of those low Earth orbit satellites, because even though the sun has set down here on Earth, it hasn't set for some of those satellites in orbit yet, so it still catches quite a few of them going across until the sun gets even lower and lower later in the evening. But for now, it's we may have to just put up with them. But alright, let's see. Let's see what our first object, and this is, these two things are right between Sagittarius and Scorpius. In the very southern sky right now, very southwestern sky. And they are kind of some of our summer pretties that are up there high in the southern sky, or at least well up in the southern sky for most of us during the peak summer months. And there's Lagoon there, and there's the Trifid Nebula there, which we're going to look at more closely. And just a really dense star field, because when we look into this area, let me show you on the Planetarium. So there is Sagittarius, the teapot, the top and the handle and the body of the pot and the spout. And then Scorpius is over here. Well, Scorpius is actually mostly set at this point. It's down here. It's the Scorpion right in there. And so these are kind of sort of in the middle, I guess sort of more above Sagittarius than anything else. But this whole area is looking right into the core of our Milky Way galaxy. So this is where the center of our Milky Way galaxy is, kind of like right above the spout of Sagittarius's teapot is where the center of our Milky Way is. And the reason it's not a lot brighter is simply because there's a lot of dust and debris and light absorbing or light blocking stuff between us and it, except for a few very small patches, one of which we'll be looking at up here, which is a small Sagittarius star cloud. We'll be taking a look at that later, which is just one little sort of window into the core of our galaxy where it gets a little bit brighter. So, hey, good to see you, Sanjeev. Welcome back. Could you take us through one end-to-end workflow with the sequencer for an object? Do you customize your sequences per object or use a more generalized one? No, I definitely use more generalized sequences. And sure, yeah, when we change objects next, we can do that. Now, before I forget here, because I've been forgetting this lately, I need to get our flats loaded. I need to get the flats loaded so that we're not getting a bright glary spot in the middle of the image. And in fact, we're going to have to start this over again because they will not balance out very well. So we'll start over again. It's okay, because this stuff is just barely still high enough that I can get we can get some captures on this. It's getting very close to setting behind a roof line for me because it's starting to get pretty low in the southern sky. See, boom, satellite right through there. And we'll clear this one again and kind of start over again. But yeah, so Trifid was really what I wanted to get here. Lagoon is mostly an emission type nebula, which is great with emission filters, which I'm not running tonight. I'm running just a UV-IR cut filter, so essentially broadband and no filtration to get the reflection nebula, which is this pretty blue stuff here that's in the Trifid nebula. And we'll talk about that in a second. I am going to clear this, and hopefully we'll get a clean first sub with no satellite in it. Let's see, yay, we got it. Okay, good. Alright, so now I should be able to successfully color balance and stretch this one so that it stays fairly clean for us. Yeah, there we go. Because this is the core of our galaxy, and there's a lot of star-forming stuff here. Lagoon Nebula's got a lot of star-forming region in it. Both of these, the Lagoon Nebula down here in the lower left, and the Trifid Nebula up in the upper right, are right about 5,000 light-years away from us. The Lagoon is about a little over 100 light-years up and 50 light-years across, so which is, thousands of times larger than our entire solar system. So it's just a massive area of gas and dust that will eventually coalesce into stars. And look at that, another satellite, but that one's kind of faint. I think we'll let that one sit. It'll get fainter and fainter. So this is all where new stars are born. In fact, there's a little cluster in here. I think this cluster right here. Let's use annotation, but it's a very young cluster of stars in here that are... Really? Okay, let's do a plate solve then. Okay, and it is 6530. Yeah, it is. This is right here is a cluster of young stars that has just recently been formed within the Lagoon Nebula. So there's a lot of star formation happening here, and young stars being born. So this is just a huge, huge cloud of gas and dust that eventually, over time, coalesces into new stars. That's how stars are born. Big clouds of gas and dust begin coalescing into lumps that, because they're lumps, they create gravity fields, which attracts more stuff, and so the lumps get bigger and attracts more gravity, and it has more gravity and attracts more stuff and more stuff and more stuff, and the thing kind of snowballs. And what you end up getting is stars form. Eventually, everything gets big enough that the gravity, the mass of the object that's forming, that's collecting more and more gas and dust and matter, eventually gets so massive by its own gravity that it crushes the core so intensely that it begins fusing chemicals, fusing stuff, and actually exploding. And it starts burning. Fusing hydrogen, and it just starts burning, and a star is born. So yeah, 10C is what I use in the summer. I'm getting ready to actually change my cooler settings to go to the winter where I use negative 10C. But in the summertime I use 10C, only because that's about the limit that my camera can maintain in the summertime. These cameras, the cooling in these cameras, the active cooling, can only do about 30 or so degrees relative to, can only drop the ambient temperature about 30 degrees. And so during the summertime, when I'm out here setting up, at first it's I'm often over 40 degrees C when I start here on summer evenings. It usually doesn't drop below 100 degrees till after midnight on some of our hotter summer evenings. So yeah, 10C plus 10C is about as cold as I can go and still have the camera effectively be able to cool things, given my start temperatures in the summer. But in the wintertime I change it to negative 10C. And they both work well. I mean, I probably don't even have to change them, but 10 plus 10C seems to work pretty well. But in the wintertime, I mean, the camera, the cooler will be off and the camera will still be colder than 10C. So I just set it for a lower temperature and it maintains nice and consistent at minus 10. The neat thing about the Trifid Nebula up here is that it contains all three kinds of nebulosity in one feature, in one structure, and that is the red emission nebula, which is mostly hydrogen. Over here, hydrogen, and the lighter parts are oxygen. And then the blue is reflection nebula. So emission nebula is basically gas, dust, and matter that is being irradiated by stars, typically young stars that are forming within these gassy areas that are creating new stars, and it irradiates the material and causes it to ionize, and basically causes it to emit its own light, independent of what's irradiating it. So they're called emission nebulae. The blue part here is the second kind of nebula, and that's a reflection nebula, and that is basically just reflecting the starlight of the stars that are in and around it. And so that's the blue over here. And then the black lines running through it, I could probably zoom in on this a little bit, the black lines running through it are dark nebulae, the third kind of nebula. And so this here is dark nebulae running this. These aren't just gaps in the red cloud, in the emission cloud. This is actually dark dust and nebulae that is actually blocking the light of these of the brighter emission nebula behind it. And so that's actually how this got its name, Trifid, which means three-lobed, because this, to the early astronomers, it made it look like these dark nebulae were splitting this into three kind of distinct lobes. I think we can probably pop that up a little bit. Oh, shoot, wrong button. But, oh, terrific. The colors are just great in this. Just great. And then Sanjeev, you asked about this sequencer. Yeah, basically I have a sequence for when you're done, basically when you've slewed onto an object and then you want to start imaging. I have a sequence that sets everything up. Sets the exposure time and sets the main display histogram back to neutral, and sets the exposure time and the gain and everything where it wants to be for actually starting to take the captures. And then when I'm done taking the capture, I'll use a different one to go to the next target, which then shortens the exposure to 1 second, maximizes the gain, stretches the display histogram so things are easier to see when you slew to them, easier to plate solve, that kind of thing. So basically the kind of things you need to do every time you shift from one object to the next and start imaging. There's kind of two phases: going to the next object and setting things up so you can easily see it and plate solve on it, and then changing all the settings to actually do the imaging. And so I have a couple of basically general sequences that do each of those things. And I have different ones depending on the gain levels that I'm using. I used to have different ones for the different cameras that I had, but I've really kind of settled on just the 183s, which continue to be my workhorse cameras. I try other cameras to see if they'll do better, and every camera I try just comes up short. Latest camera that I tried was a 585, and compared it side to side, and back to back with the 183, and the 183 still was a better sensor for, at least for my setup. So yeah, so basically at this point I only have one camera, but I run that at different gain levels depending on the types of objects that I'm looking at and whatnot. So anyway, so there's Trifid. Let's go down here and look at Lagoon a little bit more. So this is just a really pretty one. Just a big old star forming region with Bok globules, these protostar areas here with this dark, almost like dark nebulae, but this protostar matter that just it'll turn into new stars as well. I am guiding. I am guiding tonight, although with when I'm using the Hyperstar, as long as my exposures are under 2 minutes, I really don't have to guide. Here you can see my guiding is up over a little over 1, which is strain wave mounts do this. Every once in a while they go nuts for a few seconds and then settle right back out again. So that's what this is doing. I am using guiding even though I don't have to. When I'm using the Hyperstar, my exposures, I rarely need to go over 60 seconds. And so the guiding, I really don't need to guide for that. The AM5 is more than good enough to hold the targets and things as long as I keep it under 2-minute exposures, it does really well. So I don't have to guide, but because I have it already set up, I use it for other situations. Like if I have the 6.3 reducer on the back and I'm running a much higher focal length, then guiding, of course, is necessary. But I don't really need to go. Oh yeah, see how it's all turning red? See how this is all turning red here? That's because it's going into a roof line. So literally these are our last views of this object. We got a good 10 minutes on it. In fact, we can maybe unstack this last sub. And well, maybe it's going to unstack, maybe it's not. But yeah, that's why that's why this is happening. Is it's going into a roof line, and so this is all just going to turn red. So, Lagoon and Trifid, both very fun nebulas, really pretty stuff. But let's go over and do a neighbor now. Since we're getting into the roof line, we got to kind of make it quick. Okay, so here again, I'm invoking the sequence that allows me to set everything to move to a different object. In this case, we're going to go over here. That's not what we want. We want that. This will give us a few more minutes before we hit a roof line. So let's just get going. And now this sequencer, now that I'm on the object, I have all the gain and the exposure set to plate, solve, and find an object. Now I want to actually start imaging, which means it's going to turn the guiding on. It's going to set my exposure. It resets the display histogram, sets the gain properly, tells PhD to start guiding, sets the exposure to 60 seconds, resets the stack for me. Just basically all the settings that need to change for me to actually start imaging from the settings where I was when I go to slew to a new object. So he came out with the sequencer a few years ago, and I was really happy because every time I would have to do all these things manually every single time I went to a new object and started imaging on a new object. It's to do this, then do that, then do this, then do that, then do this, and then you can actually go. And invariably, a few times over the course of the night, you'd miss a step. You'd forget to do something, and your image would come out terrible. You'd slew to the wrong object. You couldn't plate solve. Something would happen because you missed one of the many steps it takes to go from one state to the other, either slewing or imaging. And so I was really happy when the sequencer came out, when Robin came out with that. Why have we got such a red here? I wonder if it's picking up my light. Well, there is what we're looking for, but well, I'll turn my headlamp off here and see if that's see if my red headlamp is causing it. If not, we might not be able to get this object, and we'll just have to move on to the next one. But I would think we'd be further off than this, so we'll find out. I had a great 533. But yeah, I did like my 533. It did work very well with my 6-inch imaging newt, which was running at about 800 millimeters of focal length. And I really did like it. It fit it had a great image scale at that focal length, and so yeah, I really did like that. But when I branched out and got a different scope, specifically in this case the C8 with the Hyperstar, I'm running, I was only running half the focal length, so I needed to get a different camera. So the 183 came in. Yeah, it's still pretty red here. Let me actually go look at the scope and see if I'm pointing at the roof. Yeah, unfortunately, we're not going to be able to catch much of this object tonight, which is a bummer. But it's just getting a little too low. So it's very low. This is my horizon here. It's just very low on the southwestern horizon, and I've got a roof line right here. So kind of catching that roof line, and there's not much we're going to be able to do about it. It's just going to make this dim and dark. It's a very cool little nebula. It's got this little snake running through it. It's a little dark lane that sort of winds its way through like a lizard or a snake, and so it's called the Chinese Dragon Nebula. And it's got a lot of the red emission, and it's got a lot of the frosted blue reflection nebula too, all over the place. And the stars themselves are almost golden in color. It's really a beautiful nebula, but unfortunately, it's just a little too late in the season to get it. It's just setting a little bit too early. So, I was hoping I could. Oh, thank you, Hudson'sism. Thank you for that. I've got just enough field of view to get Lagoon and Trifid, and that's a heck of a way to start. Unfortunately, this is not a great follow-up because I'm in a roof line and it's obscuring half of the stuff. So, but this does give you a little idea of where I talked about some of the little holes in the dark nebula and the dust and gas that's blocking our view of the core of the Milky Way. Well, here's another little window here where you can see a very dense star field. And that's not just because there are stars here and not here. It's just because this is being blocked by a lot of dark stuff. And in fact, let's go take a look at a little bit of the Sag star cloud now. And we'll come up here and take a look at this. And kind of center in there. Yeah, so we'll get a good view of some of this here, which will be a window into. Okay, so now this sequence here, Sanjeev, is now. So now I'm going to switch objects. So I want to do a next target, and so this one now stops the live stack. It runs so quickly I can't even see it. I'll actually just show you that one manually. I'll pull it up here in a second once we've done slewing to the other object. So this is IC 1284, which is just a neat little emission spot. Let's make sure I'm right on. I am. So let's start imaging at 53. Now you can see here from my cameras, I still have some of the old 585 ones in here that I can actually get rid of. But this one is I use for 53 gain. I use this one for 111 gain, which are really the two gain levels that I use for the 183. 53 is considered half unity, which is what you use for broadband, and 111 is considered full unity, which you use for narrowband stuff when I got my nebula filters and things in. So kind of showed you, where is the sequencer edit? Yeah, so this one here is start imaging. So again, it sets the gain. All these lines here, these three just reset the display histogram to neutral. This starts the guiding, sets the exposure to 60 seconds, resets the live stack, and then hides the progress when done. The other one that I use is the next target, this one. And so when I'm done imaging and I want to go to the next target, that's what this does. It stops the live stacking. It then tells it stops the guiding. It sets the exposure to 1 second, maximizes the gain, and then stretches the display histogram, which makes everything easier to see and easier to plate solve because you've got it really stretched. And then it sets the display zoom level to 0, so sometimes I zoom in on objects, and so this allows it to this sets it back to 0 so I can see the full field of view when I slew. And so that's what that one does. And so between these two between these two sequences, I'm able to get the settings I need to go between objects and then start actually imaging on an object. We've got a little bit of a satellite trail here, but it's kind of faint, so I'm going to leave it. And the next subs that come in will pretty much fade it out. If it's a real bright one, I have to kill it and start over. But this one is, yeah, see, already it faded that out pretty well. So, yeah, so this is, again, an emission area, an area of emission nebula here. And then we got a little bit of reflection nebula around these stars here. And then up here is the Sagittarius star cloud, which, again, is sort of a window, an opening in all the dark stuff that is between us and the core of our galaxy that are blocking most of its light out. This is one little opening into some of that right here, the small Sagittarius star cloud. And in fact, in dark enough skies, you can actually see this naked eye. I can see this naked eye from here, it's that bright. And if we didn't have all this dark stuff in the way, dust and gas and light-absorbing stuff and light-blocking stuff in the way, we would have a much brighter night sky in the summertime, because it would be the core of our galaxy would be glowing there quite nicely. Sanjeev says that's very cool. Glad SC Pro can now operate PhD. Yeah, oh yeah. SharpCap has been able to operate PhD2 for many years. The sequencer basically has automated a lot of that, but yes, being able to control PhD2 and your guiding with SharpCap is a pretty important thing. So it's been around for quite a long time. Actually, interestingly enough, most people don't. I mean, the sequences that I use work great for me, and I've been using them for years. But most people don't use them because there's a new functionality under Tools, the Go-To catalog, where you actually now have it set up where it does almost all of those things in an automated fashion that I do with my sequences. Now is part of this tool that Robin has set up. That's part of SharpCap now, so it's all kind of, the things I do in my sequences. He's kind of made a tool that automatically does all that stuff, and a few other little bells and whistles as well. But I tried using it, and my sequences just work better for me. I mean, his tool works for a lot of people, but it's sort of a generic tool and doesn't really take into consideration your specific hardware. My sequences I made for my specific setup, so that just works better for me. So I continue to use my sequences rather than the go-to functionality. But pretty much everything I do in my sequences can be used with that new tool. Well, relatively new. It's been around for at least a year. Relatively new tool that Robin has put in there. So, yeah. Let's see how we're doing here. I think we're doing probably okay. Stretch this a little more. Maybe a little more again. Brighten it up. Yeah, there we go. Getting a little brighter. Yeah, I've got the flats in. That's all set up there. Oh, color calibration. The background and color calibration. Yeah, Sanjeev, you had asked about that. I actually tried using that a couple times, and it just completely whacked the colors in my in my images. Admittedly, I only tried it once or twice and only briefly, but it did not work nearly as well as my own workflow does. So, again, I guess old dog and new tricks. I didn't stick with it. I just use my own color balancing in the same way I've done, just manually balancing. Well, just using the automated color balance here and doing my stretching the way I've already done it. Just seems to work for me. Seems to get me the images that I want. So I just kind of stick with it. Very dense star cloud, just thick, thick, thick with stars in the core of our galaxy. This is just another great little area of color that I like shooting. I live in very light polluted skies, Sanjeev says. It's a lifesaver for me. Gets me 95% there, although your bar is very high. Well, I've been doing it for a few years. My images are, for EAA images, my images are pretty good. For astrophotography, they're not very good, but that's because I'm only spending 10 or 15 minutes on an object typically, and astrophotography is spending a lot more time collecting a lot more data. But I just like taking quick looks at things and then moving on and looking at the next thing. I like looking at 8 or 10 or a dozen objects in a night, as opposed to the astrophotographers of the world who spend 8 or 10 or 12 hours on the same object in a night and get some stunning pictures, of course. Just not what I like to do. But I kind of I just stumbled on this little sort of vignette, this little view here. One night when I was poking around, I saw that these were here, which was kind of cool, and then you kind of get all this stuff in one view. Emission nebulae, reflection nebulae, the Sagittarius star cloud with very dense, thick stars and a great cluster right here of stars. It's kind of on the edge here. Yeah, this probably even has an NGC number. Let's take a look and see. Yeah, I can't. Can I read this? I don't know that I can read. It's so bright here that I can't read this writing. Oh, I think that's M24. It is. It's M24. Yeah. So that's actually M24. Well, I think this is actually the whole star cloud, not this individual cluster. But anyway, it's pretty nice stuff. Definitely gorgeous stuff. So definitely gorgio stuff. Oh man, I'm at 299 subscribers. I wonder who's going to be my 300th subscriber. I should have muted my mic before I took a drink. Sorry about that. And also, don't forget to hit the thumbs up when you, if you like what you're seeing. Much appreciated for the YouTube love on that. Cool. So this is a nice view here. I always kind of like this combination of objects in here. Sort of a little of everything in there, you know. In fact, I think there's even a planetary nebula in here somewhere. But anyway, what do we got next? So now we're gonna get out of the deep south here and kind of head north. Got a little ways to go. There's probably some objects in here that I could look at, but a little glob. It's a VDB object. No, it's a sharpless object, so that's very good with nebula filters. But I think our next object up the sky is going to be M27. Good old dumbbell nebula. So we'll take a look at that next. Speaking of planetary nebulae, alright, so now we'll go jump into our next target. Oh, look, it came up here because I messed with it. It's funny, it's like it started, almost like it resaved it. Huh. Interesting. That's how you make it go to the top of the list. Just resave it even if you don't make any changes. In fact, I might do that with the other ones too, just to get them at the top of the list so I don't have to go down so far. Okay, so slewing over to M27, the dumbbell nebula. There she is right there. Put you in the center. And now we'll switch to imaging mode by using the 53 gain, which is what I'm using tonight. Start imaging with the 183. Sets our gain, resets the histogram, starts guiding, sets the exposure, resets the stack, closes the window. All automated. Don't get the opportunity to miss any steps. It works great. It just works great. Oh, and I forgot to start the music, didn't I? Oh, it should be going now. Okay, so we are now on Messier 27. The dumbbell nebula. Also called apple core. It's a planetary nebula. Which I'll talk about in a second. Surrounding a white dwarf star. And this very black's clipped. So that's why we have histogram adjustments. So that we can... Oops, come on. Get that there. Yeah, there we go. It's a pretty good start. Planetary nebulae is basically a planetary nebula is a misnomer. It's actually has nothing to do with planets. When early astronomers first saw these objects, they knew they weren't stars. They were too big and round and colorful to be stars. So they thought they were planets, just like Jupiter and Saturn and Neptune and Uranus have color to them. They thought that's what they were seeing with the planetary nebulae as well. So they called them planetary nebulae. They didn't think exactly they were planets, but they just weren't sure. But they knew they weren't stars, and so the name is kind of stuck. We now know that they are actually main sequence stars that are going through their death process. Our own sun will do this in about 4.5 billion years from now, where it starts burning up its hydrogen, and it starts running out of fuel. And a star, when it's burning, when it's in its the majority of its lifespan, is a tug of war between the gravity, the mass of the star itself, the gravity sucking all of its material toward the center and crushing the center and causing it to burn, and the burning itself, which creates massive outward pressure with that huge furnace burning all that massive amount of energy. And so a star is basically the balance of those two things, the gravity pulling it in, the furnace pushing everything out. And so over the most of the life of the star, that's what it's doing. It's just sitting there and it's a star, and like right now our star is very well balanced, the gravity to the fusion going on. It's so when the fuel starts running out from the star, then what happens is the star it loses mass. It gets lighter, and the burning starts pushing outward, and it starts losing some of its mass. Some of its mass starts spinning off and expanding out away from the star, and it turns into a red giant. And so when that happens, its size greatly expands. In fact, it may expand even to the point of our sun may grow in size to the point of even consuming the Earth's orbit. And so what happens is it just keeps expanding and expanding and sloughing off these outer layers of its gas and the materials that made it up, leaving behind a much smaller core. The core doesn't go out. It's much dimmer and cooler, but it does not go out. It doesn't just like poof like a light switch. And so what it does is it actually illuminates and irradiates the gases that are expanding outward from it as it continues to burn. And so that is what a planetary nebula is. It is all the gas that used to make up the star itself that's being expanded out away from the star many light years, and the star itself, the core of the star itself, is actually illuminating all of it as it does that. And so that's what we're seeing with a planetary nebula. And the planetary nebula can have all kinds of interesting shapes. In this case, it's sort of an hourglass or apple core shape, which aligns along the magnetic poles of the neutron star, the star that's in the center of it, that is spewing all of this out, all this material out. So this kind of like you kind of got this, this cone here and another cone here, and it's sort of centered around this little star here, and a lot of the material is sort of coalescing around the magnetic poles of the star. Some of them are perfectly round, some of them are oval, some of them are all kinds of weird shapes. Just depends on how gravity is impacting them as the gas from the star spreads out into space. The star's magnetic field itself and the star's electromagnetic properties will affect it. Other planets in the solar system, if any, will affect it. Surrounding objects, that are even outside of its solar system will affect it, because it's many times the size of its solar system when it starts expanding like this. So that's a planetary nebula, and this is one of our finest examples. This is one of the largest, brightest ones in our sky, is the Dumbbell Nebula. And it's just it's a really pretty one to look at. apparently about 15,000 years old, was discovered by Charles Messier in 1764. It's about 1,400 light years away, so fairly close to us. For anyone who's actually looking for where it is, it's kind of between Sagitta and Vulpecula, neither of which are very dramatic constellations, but Aquila and Cygnus are really the main constellations that it's between. There are a couple of very small constellations there, Sagitta and Vulpecula, that are between them that don't constitute a whole lot. But it's a great binocular object. The Northern Cross, or Cygnus, the Swan, if you kind of come off its bottom star, come over a few degrees from its bottom star, you can see it in some binoculars. It's a pretty nice object. Small telescopes work really well with it as well. Nice thing about planetary nebulas, like stars, they are pretty bright objects and don't need a lot of time to see them well. So let's go to another one. The Ring Nebula. This one's going to be much smaller. This one's going to be much smaller, but bit more intense. It's actually going to be more like a ring shape, hence the name. And there it is right there, just that little guy right there. In fact, I think I'm even going to reduce my exposure down to 30 seconds. And just make a plain, whatever, it's fine. I won't use dark or flat on this. We'll just go wild and woolly here. This pretty bright, so we don't need we don't really need a whole lot of time or exposure on it. Sanjeev says 183 is a great camera. I keep going back and forth between the 2600 and 183. You have it really dialed in. Yeah. The 2600 is a very nice sensor. Obviously the two are not in the same class. 2600 is a much bigger APS-C sensor. And it's better to be used at longer focal lengths. But the 2600 is it's almost become the gold standard these days. The 2600. I've considered getting it for my setup here, but it's the pixels are too big and it doesn't give me the image scale that I want. It's basically a 533. It's 533 all over again. It's basically just the big brother of the 533. So yeah, it just doesn't Doesn't do it for my particular setup, so I've just stuck with a 183, but 2600 is a very nice camera, no doubt. Alright, let's get this cleaned up. And yeah, we don't really need to do much here. In fact, usually so this is just a really tiny object. My Hyperstar, it's such only 400 millimeters of focal length, is not the ideal device to get it, but it is a very cool little object, and you can even faintly see the star at its core. But I have to back the stretch way off. But again, as a planetary nebula, pretty much almost circular, a little bit ovalish, but similar coloring to the dumbbell that we just looked at, because it's the same kind of thing. This one, the central star, is a little bit more visible, perhaps, but it's just a cool little object. It's good to look at for a couple minutes anyway, even though this isn't the greatest setup for it. Michael, hey, how you doing tonight? I'm looking at getting a strain wave mount, and wonder if you need to do 1 or 2 star alignment or just polar alignment. All I do is polar align, because I plate solve anyway. I just plate solve everything, so I never do a 1 or 2 star alignment. I just plate solve, and you know, I just use Stellarium to send myself to an object and plate solve on it, and boom, done. Don't really need to you don't really need to do any alignment, because I'm using Stellarium, or you can use Sky Safari, whatever, to actually send your mount to objects. You don't need the mount itself to do that, so you don't really need to star align. So yes, every night I do a polar align, and SharpCap gives a great feature for that. The polar align feature in SharpCap works very well. It's quick and easy, and now that Robin a year or so ago really put SharpSolve in here, really put the plate solving engine right in SharpCap and made it super efficient, super sensitive. It also significantly improved the polar line feature, so it works really well. And so that's all I do. I just do a good polar line using the tool in SharpCap, and then I just plate solve everywhere I go, and that's all you really need. So, yes, image scale is much bigger, not ideal for finer details. No, for the 2600, that's the thing. But if you're using a scope that has 800 or more millimeters of focal length, it's great. You know, because then you've got 800 to 1,000 millimeters of focal length is about perfect for the 533/2600 family of sensors. It works right about perfect. So it's only when you get shorter than that the image scale, you really want a smaller pixel camera like the 585 or the 183, which are kind of the leading small pixel cameras that are out on the market these days. The 183, of course, having been around for many years now, it's kind of the veteran. It's kind of the old man in the group, but it works so well, providing good image scale for short focal length, wide field scopes, that everybody keeps using it because it just works great. So. Plate solve with my DOB, but my tracking only works after I do two-star alignment. Yeah. So your DOB is it's motorized. Basically, you have a motorized mount on your DOB, I guess is what you're saying. Well, yeah, it may need to do. Well, I don't know. It depends on what your DOB mount is. I'm assuming it's going to be, well, if it's a DOB, it's going to be an alt-az type of mount, and so for that you can't polar align anyway. So yeah, it's going to need 2 or 3 stars to align to know where the sky is, and how you are, which way you're facing and which way objects are moving. So yeah, that's a totally different thing. But once you go to an equatorial mount, then you just polar align, and plate solving gets you everything you need. So much simpler than my old Meade LX200 or my big Dob with servo cat. Yeah, agronavis. Yeah, so that's, yeah, all that stuff needs to know where the sky is. So, but when you go to an equatorial mount, then all you need is a polar alignment. But for those other alt-as type things, like the LX200 or your big Dob, yeah, those are alt-as. So that needs a bit of a star alignment. Okay. Well, ring, nebula, very neat, cool little object. And let's go to our next thing. What is next? We did M27. Got anybody else in here? No, nothing on this side of the meridian yet. Caldwell 4. The Iris. I love the Iris. Okay. Hello, Iris. We're going to have to wait for the rest of these guys to come across the meridian. We'll catch them as they come across one at a time. For now, we'll do the Iris. It looks like my door is still open. I guess I'm going to go fix that. Okay. Get in on the Iris here. Place. Oh shoot! You know what? I want to change this back. We need to go back to the 1 minute, and we need to get the flat reloaded. So that's all working right. Okay, good. Now, if I recall correctly, well, let's see. I think what I want to do is move. I think I want to move it to the right a bit. Uh-oh. Oh, shoot. I forgot to... Okay, we got to do the next target again, because I changed my profile. Alright, did you go the wrong way? I think you went the wrong way. Yeah, good. I think I want to move you to the right. Actually, you know what, now that I'm thinking about it. You know what, now that I think about it, I think it went up and down. Alright, let's pull a first sub. I want to catch the trail that comes off here. Oh, nuts. Okay, I'm going to have to manually move it back. Alright, let's take our first sub and see which way we need to go here. While it's doing that, I'm going to edit and resave the... Okay, so I want to bring 183, 53 gain, 183, 111 gain up. Yeah, so we just click save without making any changes, and then we open the 111 gain, this one, and we save that one. Alright, and that should allow these to come to the top of the list. Yeah. No, it didn't. Huh. I don't know why it didn't do that. Alright, well anyway. Let's see what our first image looks like. color balance, auto stretch. Yeah. I did want to bring it over to the right. Okay. I did want to bring it over to the right, so let's do that. I want to catch more of that trail. Oh, I went the wrong way again. Alright. That'll do. That'll do. Wonder why you didn't come up here. The 111 went up. Why didn't you? Make a quick change. Put it back. That'll definitely bring it up. Just wanted to be at the top of the list. Still didn't come up. Why isn't this coming up here? Oh well, not worth fussing over it. Alright, Iris Nebula. First sub coming in. Ooh, actually a chilly little breeze coming up. I may have to go get a jacket. The Iris Nebula. Love this one. It's a great little object. Works really well for my setup. Okay. Let's take a look at a wonderful reflection nebula. It's illuminated by a Mag 7 star. About 1,300 light years away and 6 light years across. Just a reflection nebula. I like it because it's also got some of this dark nebula around it as well. So as we continue to collect subs, more of this will come in. But it's just pretty cool that it's just this bright thing and surrounded by this sort of dark, ominous stuff. And we'll just go get a few subs while I go get a jacket, because it's starting to cool off. So I'll be right back. Alright, that's better. Let's see how we're doing here. Do another quick color balance. I think we're doing okay. One question: if I am in Bortle 7.8, this example, what would be a good to change? Gain or exposure, or just do color calibration histogram? Ross 8, 183, so you got similar setup to what I have. Well, I guess I'm not really sure. What do you mean? What would be good to change? Change from what? Are you having issues with it, or what needs to change, I guess is gain or exposure. Well, for a 183, just in general, like I said, there's two ideal places to run them at. A gain of 53 if you're doing broadband, which if you're in Bortle 7 and 8, you're probably not doing broadband. You're probably using some sort of filter if you're using probably some sort of filtration, at least light pollution or something like that. So you're probably going to need to be using more like 111 or even higher. Those are the two that I use, 53 and 111. But I'm not in light pollution, so you may end up having to go to higher gain to punch through whatever light pollution filters that you're using. Yeah, the Celestron light pollution. Yeah, so you may need to use more gain. F2 is really great. I love my Hyperstar, the Rasa, same thing. F2 is really great. It collects light really quickly. So if you've got, it collects the light of the object really quickly, but it also is therefore more sensitive to light pollution as well. So it's it gets that also. So typically you need to keep your exposures fairly short to keep the light pollution from collecting too much. So it's kind of a tricky thing. And quite honestly, I'm the wrong person to ask. I have no experience doing this imaging in light pollution. So actually, I shouldn't even, I shouldn't be talking about it at all, because I don't do light pollution at all, and so I'm the wrong person to ask. I'd get on Cloudy Nights, Stargazers Lounge, whatever your favorite forum is, and I'd get advice there from people who image in that kind of environment, because there are a lot of you. You're in very good company. Well, like Mike points out, seeing can be a factor. So, Mike or somebody else on this broadcast may be able to do a much better job answering than I can, because I literally don't have any experience combating light pollution when I'm trying to do my imaging. So, yeah, especially at f2. What I know about f2 is that it collects light really fast, and so the more light pollution you have, the more it's going to collect of that too, and so it gets a little tricky. The nice thing about being in dark skies is not just that your skies are dark and you have a little more contrast, but that at f2 that contrast is further enhanced. The brightness of the object is really, collected very quickly, but because there isn't any background light, your light polluted, there's no light pollution, there's the sky, you've got a lot of contrast, the sky is very dark, it does not get very boosted, obviously, and so it further increases the contrast of your already high contrast sky. And so it's something I've really found. The faster I've gone, the better my images have gotten. Not just because it's faster, but because the speed also improves contrast. It makes bright things much brighter very quickly, and things that don't have a lot of light don't get a lot of boost at all, so essentially it artificially boosts your contrast. So, yeah, I'm not the person who can talk about this with any sort of authority, I guess. What's the word I'm looking for? I have no experience with it, so unfortunately. So there you are, a very long non-answer. Yeah, my FWHM is usually not that good either. Mike talks about it being 7. Mine usually isn't, 4 or 5. This is not a bad night for me. Somewhere in the 5s. Last night I was out here and it was in the 6s and 7s. So I don't always have great FWHM. It depends a lot on the humidity level, seeing. But humidity level and transparency is a big part of that. Excuse me. So it's kind of variable. I don't typically have great FWHM though. This is such a pretty nebula. I really love doing this. We'll zoom in a bit more. Could probably go on to the next object, but I just like this one so much. So beautiful. Surrounded by all that evil blackness. Alright, well that's 15 minutes on that. Who else we got? The elephant trunk. Yeah, that's a subtle one. I like doing just the trunk part of that. It's a little bit of a subtle one, but what is this one here? The wolf. Oh, the cocoon. Oh, the cocoon's a very nice one. Yeah, we can go do that one. Alright, we'll go do that one. Next, target 183. Alright, let's go do the cocoon. Up sky. I like the cocoon. This one, I believe, comes in from either the top or the bottom. I think it comes in from the bottom. It's got a nice tail on it. But I could have that backwards. It could come in from the top. Huh, this is a sharpless number. Yeah, it comes in from the top. Oh, I got this way too stretched. Well. Back that off a bit. Got a nice trail coming off of it. I want to drop it down a little bit. I want to drop it down a little bit, so let's drop the stars down a little bit. Did that go down or up? It went down, yay. Okay. It's just... that'll be good enough. That'll work. Get a little more of that trail in there. I could have looked at it from here. Yeah, it's hard to tell where the trail is on this. From the top is right. Anyway, we'll start over again. Yes, I did. Excellent. Cocoon Nebula. Cocoon Nebula, a mix of reflection, emission, and dark, sort of like Trifid. It actually looks a bit like Trifid, the three-lobe, where it's got the dark nebula rivulets running through it. And then this trailing dark nebula that goes off above it. Quite a cool looking thing. Yeah, that's about right. But yeah, it's almost Trifid-like in the way it looks, where it's sort of broken up into lobes as well with the dark nebulates in it. And it's got the red emission, and then it's frosted by the blue reflection nebula all around it. So there's a little frosting on it. So once we get a few subs, we'll zoom in and take a closer look at it, because it's quite a nice looking object just in itself, even without the juxtaposition of its thick star field and the dark nebula tail that it has. Let's see what Wikipedia has to say. It's 4,000 light years away. And the central star that lights it formed about 100,000 years ago, so this must be a star-forming region then, because that's a very young star at 100,000 years. It's about 15 light years across. When viewing it, dark nebula Barnard 168 is an inseparable part of the experience, forming a dark lane that surrounds the cluster and projects westward, forming the appearance of a trail behind the cocoon. So Barnard 168 is the name of the dark tail that it has here, the dark nebula region. The Cocoon Nebula is a stellar nursery where star forming is ongoing. Observations by the Spitzer Space Telescope and the Chandra X-ray Observatory have collectively identified hundreds of young stellar objects. Young stars are seen in both the emission nebula, where gas has been ionized by massive young stars, and in the infrared dark molecular cloud that forms the tail. One of the most massive stars in the region is a star of class B1 that is an estimated 14 to 18 times the mass of our Sun. It's a pretty big star. So about 4,000 light years away and 15 light years across for the little nebula itself. And then Barnard 168 is the dark nebula region that goes spinning off it and forms a tail. Mike, okay, I'll watch the rest tomorrow. Thanks. Yeah, hey, Mike, thanks for being here. Appreciate you stopping in and saying hi. So it is midnight here. Okay, well, Sanjeev, you have a good night, and I'll see you later as well. Thanks for being here and having a nice conversation. I always appreciate it when people ask questions and kind of get a little banter going. Well, as banterish as it can get anyway, when it's only me talking, but it's nice having chat rather than me being here just droning on. We'll get a few more subs here and then we'll zoom in on it. Take a closer look. Meantime, the overall look I think is pretty cool. even risk zooming in a little bit more. It's such a cool looking object. I had one more balance on it. But I really like the blue frosting around the edges. Yet another beautiful star-forming region. Very cool. Okay, what else? This one, Wolf's Cave. Yeah, that one's not much. The Dark Shark. That one's very subtle. That one is very subtle. Would take some time for that to really show up. So let's do the elephant's trunk. Get in and do just that trunk section, which is up there. So maybe here. Yeah, something like that. I think will work. Very cool little object with this trail of dark sky in a sea of very thick stars. Alright, let's go do a little bit of the elephant's trunk. I like doing just this spot of the elephant's trunk. Obviously it's way too big for my field of view to catch the whole thing. But I like catching this part of it here. There's, again, some of the blue reflection nebula just sort of frosts the outer shape of the trunk itself. So, although this is another one that takes a few minutes, it's going to take several subs for it to really start showing up well. But, so we'll let this one go for a little bit. But it's a very pretty one. like shooting this target broadband. It's a large emission area, so most people shoot this with narrowband filters, nebula type filters, which cut out a lot of the reflection nebula that's in here. So a lot of this frosty blue stuff disappears when people shoot this image, because most people shoot it with nebula filters. But I really like some of the blue that shows up in here with the broadband. So it's kind of a cool object to look at with just a UV-IR cut. Lots of interesting shapes and stars in here. almost 15 minutes on that one. Neat varied object. And we can try the dark shark. It's just very subtle. Spend a little time on it, see if we can pull it out. So we haven't done any pure dark nebulae yet, so let's zoom in on that and see if we can't yeah. Alright, well, again, it's going to need a little time. Subtle dark nebulae. So you can kind of see the nose of the shark and his eye, the bottom of the mouth, even a little bit of a dorsal fin showing up here. It's very faint, very subtle, but we'll give it some time and it'll slowly come in. Lots of nice star color around here too, which is kind of cool. But we'll give this a bit. Yeah, Hudson, it was. We did get snow out here last week, or this past week. The storm that came through on Tuesday definitely did dump snow above 7,000 feet. Above about 9,500, they dumped a bunch more. The Spring Mountains got a nice coating. Mount Charleston, when I was driving into Pahrump on Wednesday morning, had a nice full bowl of snow up there. So yeah, basically above 7,000 feet got some decent snow. Thank you for being here, John. Appreciate it. I think we may have to jump the meridian here. Go get some of the next stuff. Yeah, that's kind of subtle. Cave Nebula is nice. It's going to be across in about 15 minutes. Do we wait for it? At this point we kind of have to, because otherwise if we get on it here, I'll have to come back over. So we might have to just wait for it. Spend a little more time on the dark shark. And wait for this to come across. Or skip it entirely and go do Andromeda. That might not be a bad choice. Yeah, there's the dark shark. I think we'll just go do Andromeda, flip across. Very subtle asterism, but kind of cool looking. With a little averted imagination, you can see the shark. Let's go get Andromeda. Always a nice target. Flipping the meridian. Big galaxies. Yeah, there you are. Two degrees, yep, which means it's going to be completely gonzo somewhere. And we just have to re-slew. And that'll put us in the middle. There we are. Okay. Our biggest neighbor galaxy, closest one to us, Andromeda. The only extragalactic object that we can see naked eye. If you get fairly dark skies and you can look up toward Andromeda, you can actually see it naked eye. It's the only object, extragalactic object, that can be seen naked eye. Everything else that we can see with our eyes is in the Milky Way. So this galaxy is about 2.25 million light years away. And it's approaching us too. We are going to collide in probably about another few billion years. Or a few million years. Anyway, a long time. But it's on its way. Yeah, there we are. Colors are way off, but that's why we balance the histogram. That, and then a little of this. Pull that baby in. Yeah. 1, 2, 3 galaxies in one shot. Thanks, Hudson. I enjoyed doing it. Cool, so there is the Andromeda Galaxy and friends. M110 and M32 here, just satellites of the Andromeda Galaxy. They're orbiting it. It's just like planets orbit suns, galaxies. Small galaxies orbit bigger galaxies. So, Milky Way has its satellites of dwarf galaxies as well. So, just the way things work. But that is our nearest neighbor, the Andromeda. So let's take a look at one that's a little bit further away, but not too much further, called the Triangulum Galaxy. And that's going to be right over here. No, not IC-142. Triangulum. There we are. There it is there. Oh, we'll pull it into the center anyway. It's not off by far, but Oh, thanks, Hudson. Thanks for being here. It's nice having folks who are watching. I appreciate your time. Alright. Gotta start on triangulum here. Alright, triangulum. This one is a little bit smaller and a little bit further away, so it's not going to fill our view nearly as much as Andromeda does. Andromeda is about the size of our Milky Way, and it's only about 2.25 to 2.5 million light years away. Triangulum is a bit smaller in physical size, and it's also a little bit further away at 2.75 million or so. So just a little bit smaller and a little bit dimmer. But Andromeda we're looking at sort of mostly edge on, kind of looking across the plane of the galaxy itself from one side. Triangulum we're looking at much more face on, so we get to see a lot more detail in the arms and in the core. So another fun one to spend a little time on. So we shall. Well, it has just turned into a beautiful night here. That little breeze we had earlier on has pretty much disappeared. And just calm and clear and pretty warm for, well, coming up on late October. So it's kind of our beautiful time of the year here, though. 80 degrees or 80, 85 in the daytime and 50 or so at night. Kind of like the perfect time of the year for us, October and early November. And then again in March. But between those saddle seasons, it gets pretty cold in the winter and pretty hot in the summer, so we have our extremes. But this is a pretty beautiful time right now. So again, for those just joining, this is the Triangulum galaxy, or Messier 33, for those of you who follow the Messier catalog. One of our closest companion neighbors, at only about 2.5 to 3 million light years away, which in galactic terms is right around the corner. See a lot of cool stuff in the arms of this galaxy, so it's nice to spend a little time on it. This is a slow, probably geosynchronous satellite I didn't even notice it going through here, so this was 2 frames ago, 1 frame ago, and the frame I just deleted. So unfortunately these we're going to have to live with. Totally missed them. Didn't notice that they were there. Oh well, those will fade slowly. At least I got rid of that one. Bummer. Is this the galaxy which made Vera Rubin famous for dark matter halo? I have no idea. Let's see. Let's see. Studied spiral galaxies. There's the speed of galaxies like Andromeda. So, well, galaxies like Andromeda, so presumably Andromeda and Triangulum. And so this was probably one of the galaxies that she used. Andromeda is percolating in the background there, or excuse me, Triangulum. Let's see what else we got going on here. Looks like we got the Silver Sliver Galaxy. And then there's BB15, which is a subtle reflection nebula. Mafi 1. The Hidden Galaxy. Always fun. Embryo Nebula. Well, I think I'm going to do probably about one more object and call it a night. Yeah, let's do the Silver Sliver. We're kind of in galaxy mode right now. Actually, maybe what we'll do is we'll do Ghost of Cassiopeia. These are pretty subtle. We've been done a couple of galaxies now, so let's shift back to some reflection and emission nebulae. Do those two next. that will take a little time, so we'll just finish out the evening on those. Involves a bright star and some reflection and emission nebulae. But Triangulum is always a nice one to do. It's a great galaxy. Great yellow core and lots of blue on the outer arms. Lots of knots and patches here of star activity, starburst activity. Lots of star formation going on there. They're not smooth arms. They're just kind of knotty and with these pockets of star formation and high energy stuff going on. Pretty cool. But we're going to go see Ghost of Cassiopeia. Again, a little bit of a more subtle thing, but still cool nonetheless. Yeah, I think that'll work. So these are Gamma Cassiopeia. It's a hydrogen beta region centered on the massive star system Gamma Cassiopeia. It's located approximately 10,500 light years from us. It's these two. Whoa. Something looked like it moved there. Yeah, okay. The guiding has kind of gone nuts here. Let's stop this. Refind, restart guiding. That's kind of gone wackadoodle. This needs to be cleared. The guiding kind of went nuts there for a minute, smeared everything and streaked the stars a bit. Should behave better now. This one may need to be deleted too. I think this one came through okay. Yeah, we've got another satellite. Geosynchronous that's sort of just going to pace itself through an inch at a time every sub, but it's this very bright star Navi is fluorescing this emission nebula here and causing reflected light on this reflection nebula here. So the region is surrounded by a dust shell and displays several infrared point sources that are characteristic of young stellar objects. This region includes the reflection this one here, and emission nebula, IC59 and IC63, both have a cometary shape, with 63 being the brighter of the two. The difference in appearance between the two nebulae is a consequence of their physical distance from Gamma Cassiopeia. IC63 displays a well-defined ionization front, while this is lacking in IC59. The nebulae are the closest photodissociation regions to the Sun. Photodissociation regions. Those are predominantly neutral regions of the interstellar medium in which far ultraviolet photons strongly influence the gas chemistry. Anyway, the nebula was discovered by Max Wolf in December of 1893. From the perspective of Earth, IC59, which is this one down here, is positioned in front of Gamma Cassiopeia, or Navi, and the closest tip to the star is located at a separation of 13.5 light years. It is a photodissociation region that is being sculpted by this star. Light from the star is being scattered from the nebula at an angle of 17 degrees toward the Earth. Although the tip of the nebula has been considered the closest point to Gamma Cassiopeia, the western concave face is where the most intense UV radiation is being received. Hence, the tip may actually be further away from the star than the rest of the cloud. IC63, on the other hand, which is up here, sometimes referred to as the Ghost Nebula or the Ghost of Cassiopeia, was discovered by Max Wolf on the same night as IC59 and has since been extensively studied. Spans an angular size of 10 and visible with a small telescope. From the perspective of the Earth, IC63 is positioned behind Gamma Cassiopeia, and the closest tip to the star is located at a separation of 7.5 light years. It is a photodissociation region that is being sculpted by Gamma Cassiopeia. Light from the star is being scattered from the nebula at an angle of 154 degrees toward the Earth. There is no evidence of triggered star formation in this nebula, the warmer component. Blah, blah, blah. This entire structure seems to be moving apart, and it is likely that this nebula will completely disperse within 500,000 years. So, stay tuned. A little too pink. I think we need to adjust our histogram a little. We got a little pinky there. Bring some histogram adjustments in and make things look a little bit better. Stretch it a little bit more even. What a night. Well, as we finish up this last sub, I'm going to call it a night. Had a long day today and been going for about 3 hours now, so I think it's time for me to call it a night. So, thank you everybody. Hope you had fun and saw some interesting stuff. And I will see you next time. Hopefully, maybe even in the next few days. We'll see. It's as long as this nice weather continues, I may just be on again. So, thank you everybody for showing up. I appreciate your watching, and I will see you next time. Thank you everybody.